A very good afternoon to all. Myself Pravasni Gupta, working under the supervision of Professor R.N.P. Chaudhary and Professor P.K. Mahapatra, is now going to discuss the structural and electrical characteristics of gadolinium and dysprosium based bismuth layer structure ferroelectric ceramics. This is the prototype of bismuth layer structure. This is the bismuth oxide layer and this is the pseudoperovskite layer. Here I have synthesized two BSLF materials Bi2GD ZrBO9 and Bi2dy ZrBO9. The purpose and hypothesis of my work is to verify and investigate the enhanced property as compared to the parent compound Bi3Ti and BO9. As there are no reports on the substitution of GD and Dy in the BSLF compounds, I have chosen these lanthanides at the A site and the combination of two transition elements of different oxidation state at the B site to maintain the charge balance. The zirconium 4+ and vanadium 5+ with no D electrons favor the ferroelectric properties. Further, zirconium 4+ is resistant to corrosion and makes the sample suitable for application in jet engines and space vehicles, etc. Vanadium, being the smallest ion, that is 0.54 Armstrong among the +5 oxidation state, provides larger rattling space, which in turn promotes polarization and increases the dielectric constant of the sample. Here I have obtained the solid state reaction method. As the bond dissociation energy of GDO bond, that is 716, is higher than that of 611 kJ per mole of DYO bond, the calcination and sintering temperature of BGD ZrB is higher. Here I have discussed the structural, morphological, dielectric, impedance and conductivity study. As this is the soft copy of my poster, the dimension of the graphs seems smaller. So I have segregated all these in slides for better understanding. This is the room temperature XRD pattern which crystallizes this sample in the orthorhombic crystal system. The substitution of lanthanides increases the A and B parameter and decreases the C. The BDGY, this is the same image, the BDY ZrB with a smaller grain size seems to be more densely packed as compared to BGD ZrB. This is the Nyquist plot. The single semicircle represents the contribution of only grain effect towards the total polarization of the sample. Here I have calculated the activation energy for the grain resistance of both the sample. BDY ZrB, having smaller crystallite size, possesses higher activation energy. This plot estimates the angle by which our sample deviates from the Dy behavior. This shows the dielectric characteristics of both the sample. Here at 100 Hz and 525 degrees centigrade, the ER prime of BDY ZrB is 38,281, which is higher than that of 14,494 of BJD ZrB. However, in the higher frequency, BDY ZrB possesses 307, which is smaller than that of BGD ZrB at 557. These values are better as compared to the reported values of Bi3Ti and BO9 at 1 MHz and 525 degrees centigrade. This is the room temperature hysteresis loop, and it observed that BGD ZrB possesses higher value of remnant polarization. This is the frequency dependent conductivity curves, which is well fitted with the Johnson's power law, and here we have calculated the value of frequency exponent. This shows the frequency exponent of both the samples at different temperatures, and we observed that in BGD ZrB the frequency exponent first decreases at a minimum that is 0.48218 and then again increases. Thus this follows the OLPT model, where in BDY ZrB the frequency exponent decreases with the increase in temperature. This follows the CBH model. This is the temperature dependent conductivity curves, and here the activation energy is calculated by the Arrhenius equation. In BGD ZrB The lower activation energy facilitates more charge excitation and their movement to the boundary, resulting higher value of dielectric constant. Thus, we can say that these lanthanide based compounds are more stable than that of Bi based compounds and will have better demand in the ferroelectric industry. Further, the higher value of dielectric constant, low value of tan delta and the higher remnant polarization of BGD ZRB makes it a better candidate.